Hello class. Today we will discuss on the following objectives. The first objective would be the general eigenvalue problem. These eigenvalues problems helps in the calculations of the principal stresses as well as the principal strains. The word principals over here means with respect to both stresses and the strains. This means that on those particular planes only the values of the normal stresses or the normal strains exist and no values of the shearing stresses acts on that particular plane. Next is the derivations of the field variables. These field variables can be scalar field variables, it can be the displacement field variables or a vector field variables, it can also be a tensor field variables. Thereafter we will move to the introductions of the tensors. The tensors we have studied, the tensors are the scalar quantities are called as the zeroth order tensor. The vector quantities are known as the first order tensors, and the stresses and the strains are known as the second order tensor. Eigenvalue problem. The characteristics equations of a general eigenvalue problems is given by a minus lambda I is equal to 0, or the other way of representing this equations in terms of the index notations, which is given by a subscript ij minus lambda multiplied by chronicle delta ij is equal to 0. Both are the same equations. The second, this equations is written in terms of the index notations. In this equations, the a represents the stress tensor or the strain tensors. Here I have taken the values of the A as a 3 by 3 matrix. This means that we are working in a three-dimensional Cartesian coordinate systems. In this case, we will have a total 9 quantities to define the stress at a particular place at a particular point. So the values of A can be either the stress quantities or it can be the strain quantities. So if A is a 3 by 3 matrix or the tensor, the solutions of this equations is given by minus lambda to the power 3 plus I1 lambda square minus I2 lambda plus I3 is equal to 0. So this is a cubic equations because the power of lambda is 3. So from this equation we can get 3 roots of this equation. There can be 3 roots of this equation. The terms I1 represents the trace of the tensor, which is the sum of all the diagonal terms. If we are talking in terms of the principal stresses, we will be telling it sigma 11, sigma 22 and sigma 33. Whereas if we are telling it in the general terms, we will tell it sigma xx, sigma yy plus sigma zz. So the second term sigma I2 represents this values, and the third term I3 represents the determinant of this matrix, which is 3 by 3 matrix. So we have three values I1, I2 and I3. The purpose of giving a different notations to these quantities was that these equations should look compact. Now these three quantities I1, I2 and I3 are known as the invariants. This means that they do not change. If we are talking in terms of the stresses, these three quantities remains the same. Over here it is written the same thing. I1, I2 and I3 are the invariants which remains constants and do not change with the rotations of the axis. So at a particular point a number of planes can pass, and passing through all these planes or a number of planes as at a point it passes, so we can have any values of the stresses and any values of the strains on different planes we can have. But these quantities I1, I2 and I3 which will remain the same even if we change the angles of the reference. Now we will do a numerical example on how we can calculate the eigenvalues and the eigen vectors. So the problem statement is find the eigenvalues and the vector of the matrix which is given. It is a 3 by 3 matrix. This means that we will be working in the three-dimensional space, and these values, we have the different values of the stresses. All these values will be termed as the normal stresses, and all other values apart from these will be termed as the shear stresses. So the applications we will see over here, the applications of the mathematics in calculations of the principal stresses and the principal strains, as well as the shearing stresses acting at a particular point. So the values of the I1 we can calculate from the previous equations we have seen. The values of I1 is the sum of all the diagonal elements. So what are all the diagonal elements? So these are the diagonal elements. It will give us the values of I1 which is equal to 2. The values of I2, again the from the characteristics equations, the different notations we have used I1, I2 and I3. From there I can calculate the values of I2 by this values. The different terms of the determinants of the subsections, the values would be 6. Second, the values would be minus 25, and the third would be minus 6. So it will give a values of I2 as minus 25. The third one is the determinant of the matrix which will give us a values of minus 50. So we know the three different values of I1. Three different values we have came to know: the values of I1, the values of I2 and the values of I3. Now we will put these values of I1 and I2 and I3 in the characteristics equations, which is the solutions of A minus lambda I. We will put these values I1, I2 and I3. After putting these values, we will solve this cubic equations, and when we are solving these cubic equations, we will get three values of the lambda. So the values of lambda 1, say it is 2, the values of lambda 2 is minus 5, and the values of lambda 3 is equal to 5. So if these values are in terms of the stresses, then these values lambda 1, lambda 2 and lambda 3 will be the principal stresses acting. The three values of the principal stresses acting at a point. Why three values? Because we are working in a two-dimensional space. If we were working in a two-dimensional space, we will get two values of the lambda 1 and the lambda 2. If we are working in a three-dimensional space, we would be getting three values of the lambda 1, lambda 2 and the lambda 3. If the matrix we have selected it is in terms of the stresses, these three values would be the values of the principal stresses, which is sigma 11, sigma 22 and sigma 33. We will discuss all these things in details when we will study the formulations of the stress and the strains. For the time being, we will appreciate the mathematical formulations, how we can interpret these results in the physical formations of the problems on physics. Now we have got three different values of the lambda 1, lambda 2 and lambda 3. These are known as the eigenvalues, and now with respect to these eigenvalues we are interested in calculating the eigenvectors. So we will have to put these values of lambda 1, lambda 2 and lambda 3 one by one in order to calculate the eigenvectors corresponding to these eigenvalues. So if we put the values of the lambda one by one in the characteristic equation, so what is the characteristic equation? It is a minus lambda 1. We will get the values of the eigen vectors. So if we put the values of lambda 3 is equal to 5, we will get again three values of eigen vectors, which are L1, L2, L1, M1 and N1. Over here, A is the matrix which is given in the questions. So this one is the matrix given in the questions. 5 is the values of the eigen value which we have calculated by solving the cubic equations. I is the identity matrix, or it is the Kronecker delta. So if we solve these equations, it is in the forms of A minus lambda I. We will get the values of L1, M1 and N1. So we have got the values of eigenvectors. So these are the eigenvectors corresponding to a eigenvalue of 5. Similarly, we can calculate the other values. That other values will be L2, M2, N2, L3, M3 and N3. How we will calculate other sets of the values corresponding to the different values of the other eigenvalues which we have calculated apart from lambda is equal to 5. Similarly, we will put the values of lambda is equal to minus 5 and lambda is equal to 2 one by one in this equations. In this equations, then we will get other sets of the eigen vectors. So in the first case, when we have put the values of lambda is equal to lambda 3 is equal to 5, we have got the values of the eigen vectors as L1, M1 and N1, which is 1 0 1. So these represents the eigenvectors corresponding to a eigenvalues of 5. Next sets of equations, next sets of the values we can get by putting the values of lambda is equal to minus 5. We will get these sets of equations, these sets of the values, which are the eigenvectors corresponding to a values of minus 5, and the other sets of values of the eigenvectors when we keep the values of lambda is equal to 2. So what are these values? L1, M1 and N1. Different sets of the values of L1, M1 and N1. So actually these are the direction cosines associated with these eigen values.